going to talk about 209 minimum size subarray sum. The question is given an array of positive integer numbers and a positive integer target. Return the minimum length of a subarray whose summer is greater and or equal to the target. If there is no such subarray, return 0 instead. Okay, so the target is 7 equal to 7, and numbers is equal to the 2, 3, 1, 2, 4, 3. So this index 1, 2, 3, 4, 5. Okay. The subarray for 5 has the minimal length under the problem constraint. Okay, for 3 here. We need to find the greater one. Just on the larger and equal than the 7. And then return the length. Okay, so we have to calculate the current, which means we need to first find the subarray, right? Subarray. And then also calculate the sum of the subarray. But we already find it, and then update the global and to check whether larger target. And then if this, then update the global result, or the current global result is substring length. Substring satisfy condition. Okay, so translate these problems into, we need to find the subarray. So for this one, I need like the left, where the left and the right it is, then we can calculate the length is equal to the right minus left plus 1. And for this one, we can handle like sub results, right, to check curve sum. And every time you update the right part, which means need to also update the curve sum. And if every time you remove the left one, you should minus the sum. And which means we need a curve sum to handle the substring sum. Okay, so this is the basic idea. It's also kind of like a slide window, right? Current here, it's right here, and this is the left, and then we calculate all of them over here, whether enough. If not enough, I move the right, right? So yeah, let's write the code. It's based on the logic from here. So we need to update and initialize something. At the beginning, the result should be because we want to find the minimum size. So we need to initialize its maximum. no such. Okay, it's already give us the return the 0 instead, right? Okay, we can directly return 0. So we have some base case, can check if target and there's this numbers is, see, you can, it's a 0, right? It's from all the positive, so the target is also the same positive. And start from 1. So if the target is equal to 1, and we have to check numbers whether equal to not. So we still need to check numbers. So if the numbers, so this is already satisfied, no too much special base case can we do here. We can check some base case, right? Like if the target equal to 1 or no need to check base case. This is already satisfied. So we can start do some logic here. The right is equal to for loop. Equal to 0. Right, plus plus. Okay, this right is finished. Then we can keep moving. We can know current substring length. And also I needed the int cur sum. Different 0. Int cur is equal to the numbers right. Now we can update cur sum equal to cur sum plus cur. If cur sum is large and equal than target, now we need to handle the whether two option, whether update the right, or remove the left. So we have to check wire the cur sum minus numbers left is still larger than the target. We can remove the, we can left plus plus. And cur sum can numbers left. Cur sum equal to the cur sum. Okay, current now, which means we can make sure the shortest is make sure the shortest length handle the achieve the condition. Okay, so for now we can update the this called what? Update the check left. Check left. It's called update right. Now we can update the global results. Result equal to the minimum. This should be the integer maximum. If not, this is always be the that. And if didn't find it somewhere, we also need to check here. Check without whether it exists. Okay, so minimal redout with current curl length into curl equal to the right minus left plus 1. Okay, so this is one, update the right, check for the left. Now we have another condition is the curl sum smaller than target. So we just continue. Okay, so for here, if the redout still equal to the initialize, which means we didn't find it, we return 0. If not, we need to return find the redout. Yeah, let's see. Yep. And for the time complexity, we just used we didn't create extra space and just the for loop. And for this inside, it's kind of like for the right pointer, it's just one time for loop, and inside the left move is also left, just the move. The maximum is the check all of them. So it's kind of like 2n. So for the time space, we can treat it like O1 time, and space just O1. Yeah. So this is the solution about this problem. We already submit. Yeah. So let's summarize these problems again. So the minimum subarray length, we have to check they also have some conditions here, target, right? So at the beginning, I need to initialize some numbers, like it's a slide window to handle the subarray for here, right? Use the slide window to handle the subarray. And also this is a subarray, and there have some conditions. We need to check whether current sum is larger than the target. If large, and we're trying to move the left to check whether if move the left one, we also satisfy the condition. If not, which means current now is the minimum size subarray. If it can move, so we can smaller the subarray, then we can find the minimal the subarray sum and compare with the global redout. If this condition is not satisfied, which means our current slide window actually is invalid, so we don't need to update the global redout. So just to keep continue. So everything finished, which means if we find some subarray can satisfy these conditions, we will change these initialized numbers. If not, which means we didn't find the valid window, so we just based on the problems here return 0. This is this problem solution. Thank you.